In this video, we're going to look at the periodic table and we're going to classify the elements into groups. And so as we go through these terms, I'm going to be checking them off. So the groups are the vertical columns on the periodic table. And so if I go over here, I can see that all of these elements are in the same vertical column. So all of these elements are in the same group, and we call this group 1. I can see that all of these elements are also in the same column, right? So all these elements are in the same group, and we call this group 2. I can continue labeling my groups. This would be group 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then I go back up to here and I can see I have another vertical column, so group 13, 14, 15, 16, 17, and finally 18. So that's one way to number your groups. There is another way to number your groups, and that would be to say that group 1 is group 1A, group 2 is group 2A. And then, kind of ignoring groups 3 through 12, continue on with your numbering system. So 1A, 2A, that would make this group 3A, group 4A, group 5A, group 6A, 7A, and finally 8A. And the second way of numbering your groups is useful when you're thinking about valence electrons. And so let's move on to the concept of periods, right? So a period is a horizontal row on the periodic table. And so if I look at period 1, and I just move across my periodic table, right? Hydrogen is in the first period, and so is helium. I move on to the second period, so lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. And so I can continue with numbering my periods. So this would be period 3, 4, 5, and 6. Now notice I don't have the entire periodic table on this video. I didn't have enough room, and we're not really going to talk about all of those elements anyway. So let's go ahead and focus on metals next, and so let's talk about the alkali metals. And so when I'm talking about metals, I'm going to try to write in red here. So the alkali metals are found in group 1 or group 1A. So things like lithium and sodium, potassium, right? So here are my alkali metals. The alkali metals are soft silvery metals that are extremely reactive. And one nice thing about organizing the elements into groups is elements in the same group have similar chemical properties, and so the alkali metals react in similar ways. For example, all the alkali metals will react with water, and the alkali metals turn out to be so reactive that you're not going to find them in their pure state in nature. You're not going to walk outside and find some sodium lying on the ground. Okay, they're found in nature in combination with other elements. All right, let's talk about hydrogen, because hydrogen is also in group 1, but hydrogen is not an alkali metal. Hydrogen is a non-metal. So let me go ahead and draw that in green here. So I will represent non-metals in green. So hydrogen is the exception in group 1. Next, let's talk about the alkaline earth metals. So you find those in group 2 or group 2A, so right in here. So things like magnesium and calcium and strontium are your alkaline earth metals. Your alkaline earth metals are reactive, not quite as reactive as the metals in group 1, but you don't find these in the pure state either. You find them in combination with other elements. And so once again, the alkaline earth metals are going to react in similar ways. They have similar chemical properties, and so that's, again, a convenient way of organizing the periodic table into groups. So for right now, let's just go ahead and say groups 3 through 12, right? These are all metals in here. And let's just talk about metals in general for a minute. So metals, the properties of metals. So metals are solids at room temperature, except for mercury. So here is mercury down here, which is a liquid at room temperature. Metals are very malleable, which means that you can form them into different shapes. They're very workable. They're not brittle. Metals are also ductile, which means you can draw them into wires. You can form them into wires. For example, like copper. So here's copper right here. So copper wires, of course, carry current in homes, right? So metals are good conductors of heat and electricity, and so those are the properties of metals that most textbooks will talk about. So let's contrast those with nonmetals. right? So nonmetals, if you have a solid nonmetal, those solids would tend to be brittle, not malleable like metals. Nonmetals are poor conductors of heat and electricity. So you find nonmetals in different states of matter. So let's talk about one of the nonmetals now, and that would be the halogens. And so let's find the halogens on our periodic table. You find them in group 7A or group 17, and so things like fluorine, chlorine, bromine. So here are your halogens right in here. So halogens are very reactive nonmetals. So they're often very colorful, very corrosive. And the name halogen actually means salt former, and so we're actually going to come back to that in the next video when we look at some electron configurations and we talk about why these things are so reactive. And so those are the halogens. Next, let's find the noble gases. So the noble gases are found in group 8A or group 18. So some of these are very famous, like helium, neon, argon, krypton. All right, so here are your noble gases. They're colorless gases, and they're generally very unreactive. And so once again, we'll talk about why in the next video when we talk about some electron configurations. All right, so there are some other nonmetals on here, which I will identify in a minute. First, I want to talk about the fact that you pretty much find metals on the left side of the periodic table, right? So let me go back to the red color, and you can see, right, I have all these metals over here on the left side. And then for my nonmetals, right, in green, you're going to find those over here on the right side of your periodic table. And so the dividing line between those, let me go ahead and draw it in there. It's kind of a zigzag line. So let me see if I can sketch it in here. So the dividing line would go something like this. All right, so we're going to go a zigzag line down our periodic table. And some of the elements that you find on this zigzag line have properties in between those of metals and nonmetals, and we call those metalloids. So let's go ahead and talk about metalloids now. So metalloids, right, oid of course being like a metal, so it's similar to metals, but again the properties are in between those of a metal and a nonmetal. So some of the elements that are considered to be metalloids would be boron right in here, so silicon, germanium, arsenic, antimony, tellurium, and sometimes you'll see acetine listed as one. So it depends on which textbook that you're looking in. So you can see that some of the elements along this zigzag line are considered to be metalloids, and there's no official one definition for which elements are considered to be metalloids, and so you might see a little bit of a discrepancy there for some of these elements. But in general, those are the ones that are considered to be metalloids, and silicon probably being the most famous one, right? So silicon is a semiconductor, right? So it's a metalloid, so it's like a metal, so it does conduct electricity, but not to the same extent that a metal would. And so these intermediate properties are sometimes useful. And so let's go ahead and mark some of the rest of these, right? So these would be some other metals, right? And then over here on the right would be the rest of your nonmetals here. So carbon is a nonmetal, nitrogen is nonmetal, oxygen is nonmetal, phosphorus, sulfur, and so that's just a quick way to divide the periodic table up with some simple definitions. All right, so in the next video we'll talk more about the electronic structure and we'll get into definition of transition metals.